Let's take a look at the quanta of the decay products of the C-quark. First, we'll look at electric charge. Now, initially, these particle-antiparticle pairs were not expressed, and we had only this dual relating V-rishon combined with these anti-V-rishons to give us a C-quark. And so the electric charge would be the sum of a 2/3 on this dual relating V-rishon plus the 0 on each of these anti-V's, giving us 2/3 for the initial C-quark, which is the indicated electric charge for the C-quark. Now, let us look at the decay products and see if we result with the same 2/3. First, the electric charge on the anti-U and the D-quark and this boson plus sum to 0. And then we have the electric charge of these two weakly interacting massive particles, which both also sum to 0, leaving us only the anti-electron and the neutrino. The neutrino, we can see, has an electric charge of 0, and the anti-electron has an electric charge of 1. And if we look at the S-quark, the S-quark will have an electric charge of minus 2/3 plus 1/3, which is minus 1/3. The minus 1/3 plus the electric charge of 1 on the antineutrino will give us the 2/3 that we initially started with on the C-quark. Because the Z boson, or boson 0 here, also will contribute only a 0 for the electric charge. Now let us look at isotopic spin. Again, the particle-antiparticle pairs were not expressed initially, and so we only need to look at the isotopic spin of the dual relating V-rishon and these two V-rishons, and we can see that it's 1/3 on the dual relating V and a combined minus 1/3 on the V-rishons, which gives us a total of 0 for the isotopic spin of the initial C-quark, which is the isotopic spin indicated for the C-quark. Now, let's see if our resulting decay products give us 0 also. Again, if we look at the isotopic spin here, we have minus 1/2 and minus 1/2, which is minus 1. And then over here we have a plus 1, and so that sums to 0. And then we have, for the anti-electron and the neutrino, we have a plus 1/2 and a plus 1/2 for the neutrino, which gives us plus 1. But if we look at the weakly interacting massive bosons, they also give us the opposite, minus 1/2 and minus 1/2. So the minus 1/2, the minus 1 isotopic spin of these weakly interacting massive particles cancels the plus 1 isotopic spin of the anti-electron and the neutrino. That then leaves us only the S-quark itself, which has an isotopic spin of 0 as indicated by the standard model. 1/6 plus 1/6 is 1/3 plus minus 1/3 is 0. And the Z boson, we can see, also has an isotopic spin of 0. So we started with an initial isotopic spin of 0, and we end with an isotopic spin of 0.